Yes, good evening. Welcome to Life Made Up of Questions. Today our guest is Dr. Sumit Kumar. So I'm giving a brief introduction about Dr. Sumit Kumar. Sumit Kumar, a member of IEEE, received his B.Tech in Electronics and Communication Engineering from Gurukula Kangri University in Haridwar, India, 2008. His Masters of Science, that is MS in Wireless Communication and Signal Processing from the International Institute of Information Technology, that is IIIT Hyderabad, India during 2014, and he received his Ph.D. in wireless communication from Eurecom, France, 2019. During his master's, he worked on several projects funded by the Department of Science and Technology, India. His PhD thesis was devoted to interference management and coexistence of wireless system, where architecture for a multi-standard software-defined radio receiver was developed and demonstrated. In 2019, he joined the SIGCOM research group, Interdisciplinary Centre for Security, Reliability and Trust at University of Luxembourg, Luxembourg as a research associate. He is involved in several European Space Agency and Luxembourg national projects related to 5G, 5G non-terrestrial networks, EMF radiation and satellite communication. His research interests include software-defined radio, interference management, 5G, GTN, and computer networking. So welcome, Sumit. Welcome to this forum.
Thank you very much for the introduction.
Yeah, because long back I have met him at IIIT Hyderabad. I still remembering those days. So from there onwards,
Yes.
he was associated with software defined radio. So coming into this discussion, my first question is related to many people may be confused with the term software defined radio, whether it's something related to radio. But actually, when we are searching, we'll be getting the idea what is software defined radio and how it can be used for all sort of communication analysis and how it can be linked with hardwares. So please, what is software defined radio? What is the main basic concept? And the USRP
The
kit we are
basic,
having. Yeah.
well, in the layman terms, is we have two types of radio. One is hardware defined, where you have, if you open a radio, which was like 15 years or 20 years back, if you just open it out, you will see capacitors, resistors, several ICs, and knobs and everything. So they are completely hardware defined. You cannot, they were programmed they were made to do one specific task, and they will do that only. You cannot change that. If you want to do anything else, you have to buy a new radio. But then as the things evolved, the concept of software defined radio came into picture. So now we have something called a programmable ICs or programmable DSP cores or programmable FPGAs, on which you write the program, and then you can use it for multiple protocols. Suppose one day you can use it for 2G, next day you can program it for 3G, and then 4G and 5G. And now with the evolution of SDR, several generations of SDR, thanks to many international vendors, now we really have something which we can call an ideal SDR, which was not the case like 10, 12 years back. So, but now we have some vendors like ATAS and we do have SDRs on which you can, from top to end, you can define a radio protocol purely in software.
Okay, fine. So coming into this 5G, now we are moving into the 5G communication. So how it can be linked with software defined radios, the 5G communication?
Well, there is software defined radio is as useful to 2G, 3G, 4G, same as it will be useful for the 5G. Software defined radio is not going to provide any added advantage to 5G. It is just as one more protocol which can be implemented on software defined radio. And that is the beauty, actually, that is the beauty of software defined radio. The hardware which we are using for 3G, now we are using the same hardware for 4G. And when the 5G protocol came, we didn't have to change our hardware or the radio front end at all. We are using the same hardware for 5G also. And that's actually a beauty of SDR.
So in SDR, we used to have a lot of spectrum sensing. So what will be the spectrum of 5G and how the spectrum allocation related to 5G? How it will be like?
Well, the spectrum allocation in 5G, okay, so in LTE, we were working on sub 6 gigahertz band, which was less than 6 gigahertz. In 5G, now we have two bands. It's called FR1 and FR2. FR1 is sub 6 gigahertz, and FR2, which you also might have heard, it's called millimeter waves. So 5G is going to be allocated in sub 6 gigahertz as well as, well, it's not now the sub 6 gigahertz has been extended a little bit more. It's up to 7.12 gigahertz. And then you have the millimeter waves. So frequency allocation wise, yes, now will be in FR1 and FR2. But the main difference of 5G with respect to 4G is the subcarrier spacing. So in 4G LTE, the subcarrier spacing was fixed. It was 15 kilohertz. Of course, both 5G and 4G are still OFDM, but the subcarrier spacing is now flexible. And with that, you can have several use cases, which were once upon a time, they were just in the concept. Now they can be in reality. For example, uh, ultra reliable low latency communication and 10 Gbps of throughput. Now with these, one of the features, which is subcarrier spacing, flexible subcarrier spacing, which we also call numerology. So with this flexible numerology, now many things are possible in 5G, which were not earlier possible with 4G.
So when I am thinking about software radio, I still remember that using that USRP kit, Universal Serial Radio. So what are the other which can be linked with software defined radio, like USRP, any other hardwares or something like that?
Well, USRP is the dominant one, but it is not the best one. So dominant one in academics, because this is the cheapest SDR which you can use in academics. And it can prototype all the standards which are available, all the telecommunication standards and satellite communication standards so far. For example, 2G, 3G, 4G, 5G, and if we come to satellite standards, then DVB-S2, DVB-S2X, these things can be prototyped on USRP. But USRP is not the only one SDR which is available. However, the other SDRs are either very costly to afford in academics, or they are too cheap, that their performance, the noise performance and other things are not suitable to do any proof of concept prototyping.
Okay, when coming to a radio into software defined radio implementation related to 5G and non-terrestrial networks. So many people may not be aware of non-terrestrial networks. We have heard of several other networks. So it may be linked with satellite networking. So what is these non-terrestrial networks?
Okay, I mean, non-terrestrial network is kind of a blanket term which covers anything which is flying and providing you communication. For example, a UAV which is flying and it is able to relay the signal from one user to the another. That is the very first crude definition of a non-terrestrial network. Basically, anything which is flying, it is non-terrestrial. So if we talk about non-terrestrial network, then on the first level, we can have UAV. And if we go even higher, then we can have those balloons. They are very big balloons, gas balloons, and on which you can mount a base station, fly it up. If you go even higher, then we have satellite constellations of LEO satellites. You might be aware of that. We have three constellations, LEO, MEO, and GEO. So if you are going to mount your communication equipment on those LEO, MEO, and GEO devices, then this is called non-terrestrial network. But the satellites are already there since 50, 60, 70 years. Why the non-terrestrial network is getting pace these days? Because now we are using the terrestrial communication protocols on the satellite. Previously, what was happening on the satellites, we were having satellite specific standards. Like, for example, we were using DVB protocols. But now we are going to deploy the same protocol, the same waveform of 4G or 5G, which we are using on terrestrial use cases on the satellite. So there is no satellite specific waveform, but satellite will just act as a relay, or sometimes we will mount the entire base station on the satellite. So there was no difference of the waveform, just your coverage and the range will be extended, because by default, since the satellite are very high, their footprint is very, very big compared to terrestrial base station. And this has been recently if you are aware, then there's an organization called 3GPP, which does a standardization of the terrestrial communication protocols. So previously they were involved only in the standardization of terrestrial network protocols. But for the very first time in the 3GPP release 17, which has been frozen this year in April, first time the satellite components are included in the terrestrial network ecosystem. So now we can say that the satellite are going to be an integral part of the overall communication system.
So coming to the SDR implementation related to 5G and NTN, your postdoc subject also. So how we are incorporating all these things together? What are the challenges which you're facing?
Well, I mean, this is one of the topics of my postdoc, and this is the most interesting topic. So from SDR wise, we did not face any problem. As I said that from SDR point of view, there is no problem whether you implement 4G or 5G or 3G. But we did face problem when we tried to use the same terrestrial network protocol on the satellite. Because if you see any terrestrial network protocol, let's say start with the 4G, any type of communication is bidirectional between the base station and the user. It's a closed loop communication, and there is a timing.
Yes.
There is a timing. If you send something, and then the reply has to come, the response has to come from the another end within a specified time. So for the terrestrial network, it was tuned for like maximum 1 millisecond. For 5G, it is 1 millisecond, and when 4G, it was 10 milliseconds approximately. But if you consider about the satellites, the geo satellites, let's say geo satellites, the round trip time is 520 milliseconds. This is 52 times more. And because of this, if you use the terrestrial protocols as it is on the satellites, nothing is going to work. Starting from the physical layer itself, nothing is going to work. There is no signal surge, there is no random access, and forget about the MAC layers and other layers. So these were the very significant problems which we have to face. And thanks to the SDR, because the code was not hard-coded in any box, any hardware, we simply use the same SDR which we were using for the 4G, and we simply did all the modification in software. We took the code from, if you are aware about open interface, this is also open source implementation of 5G protocol stack. So we take the code which was used for terrestrial communication. We did modification only and purely in software and use the same hardware, and we made it work over a geo constellation. So at the when we did the final experimentation, the base station of the 5G was situated in Munich, and there was a geo satellite from Astra, and the UE was located at Luxembourg. So it was like more than 6,000 kilometers, and through the satellite we made a 5G connection. So yes, we did not made any hardware modification. We did all the changes purely in software. So it was a purely software defined solution.
So what are all the future enhancement for your existing studies regarding this implementation?
Okay, so right now we did the implementation on geo constellation. And geo constellation, as you know, so this is Earth, and you have the geo satellite. So it is not moving with respect to the Earth. It rotates along with the Earth. The next step is, but the delay is very high because the geo satellite is very high, like 36,000 kilometers approximately. The next step is to do the same experiments with a LEO satellite, which is around, I forgot the distance, but the challenge is it is close to the Earth. The delay is less, but it moves very, very fast. So you have to tackle with the Doppler because the satellite is moving super fast. And then you have to tackle with the handovers because you will see the satellite just for a couple of minutes. And then you have to again break the contact with the satellite and make connection with the another satellite, which is incoming. So and as we speak, the internet connection in this laptop which I'm having is through a Starlink constellation. If you are aware of the Starlink,
yes.
So we have a Starlink dish outside, which is a LEO-based satellite, LEO-based internet provider. So My internet connection is coming from that, and I hopefully you are not getting any disturbance in the video.
Yeah, I'm coming to that point. What are all the interference associated with such communication? What are the common interferences, and whether it may be having some noises or some any
Yes,
losses?
yes. So the band which has been allocated for NTN is very close to or sometimes overlapping with the bands which were previously used for weather radars and sometimes for army radars. So now this has become a matter of concern, especially when the LEO satellite is there. So because no, like 5 6 years back, no one knew that 5G will be coming through satellite, but
Yes.
now it has become a reality. So now if the bands which are allocated for this 5G NTN or in future 6G NTN, the bands are very close or sometimes overlapping with those, the bands which were previously for radar, weather purpose, military purpose. So yeah, their concerns are being raised about this. And
Okay.
I remember like 8 months back when the FR2, the millimeter wave, when it was deployed in US, then for 1 day, the entire flight services were disrupted because the flight, when the altimeter which the flight used to find the distance from the flight to the ground, apparently used the same frequency which the deployed 5G was using there. So it became a hot topic in the news how to tackle these things.
Okay. So other than SDR, what can be linked with this your proposed methodology in future enhancement?
Uh, well, if we since currently I'm working on NTN, so I can say something about that. The experiments which we are doing, we have not put the entire base. Our base station is still on the ground. The equipment, the mobile equipment, our mobile is still on the ground. The satellite is simply acting as a relay. But in ideal situation, the base station shall go com completely on the satellite.
Yes.
But this is not very straightforward because satellite doesn't have that much processing power and does not have that much battery power as compared to the base station, which is on the ground, which has unlimited power processing power, unlimited and uninterrupted power supply. So there is a concept called functional split where the 5G functionalities are separated. Like in 5G, we have several layers, layer 1, 5, MAC, RLC, PDC, PRRC. So there is something called separation, functional split. The idea is to have some of the functions on the satellite and while some of the functions on the ground. In this way, we can make sure that the satellite is able to process some of the functionalities of the satellite of the GNOD B. And while the functionalities which are not time critical and which take a lot of processing power, they can still stay on the ground. And then we can connect them through the standard interface. So this is the thing which I am currently focusing on right now. And apart from this, I can also, I mean, 5G NTN is one of the project which I am working. Apart from that, we are also working on EMF measurement because if I'm not sure whether in India this topic is not arranged as of now, but in this part of world where I am living, people are very much concerned about the EMF generated by 5G and the health concerns, especially because of the application of FR2, the millimeter wave, and the beam forming. So when we say beam forming, some visualization comes into our mind that a laser beam is being focused towards us and it is going to burn us, something like that. The same, so when the beam forming based systems are being deployed, also called active antenna system, the concern among the people is very grave. And I'm not sure if you have heard about the incidents where they are vandalizing the 5G towers, burning the 5G towers in UK. There has been so many incidents because of these things. So we are working in this aspect also.
So when it's come to, as you have mentioned that your research work on this, what will be the drawbacks of such cases like the radiation and other concerns?
Okay. this is the thing on which I am working right now, and it is too early to jump to a conclusion. There are some use cases when you can have very high radiation, especially especially when, for example, we did some measurement campaign, and we found that the downlink interference, the downlink when we have some devices to measure the EMF. So when in the case of downlink, when the mobile signal is very low, for example, if you see the bar in your mobiles 1, 2, 3, 4, 5, if the bar is very low, means you are very far away from the base station. In that case, you can have a very significant amount of radiation coming towards you. And this applies for both downlink as well as uplink. So even so, if you have a very low RSRP in your mobile, that is a low number of bars, and you try to call someone, that means the mobile is trying very too hard to reach to the base station. That is, it is pushing out lots of power towards the base station, because the signal is low, it has to transmit with a lot of power, and then you put it towards your head, then it's very, very high compared to what is specified in the standards. But if you are very close to the base station, then the EMF which you receive is not that low, which is very opposite to what people think, that if we are near to the base station, we are having a very high radiation. This is not correct. If you are near to the base station, then the amount of radiation you will receive is very, very low compared to when you are far away from the base station and try to make a call.
Similarly, during hands-off also these cases can happen, right? This radiation, like moving from one to the other while traveling, or moving to one location to the other, the same thing can happen.
Yes, exactly. You might have experienced when you travel in train, and if you keep your mobile always on, the battery drains very fast, because the 4G and 5G they are designed in such a way that they always have to be connected with a base station, whether you are doing, even if you are not doing anything, they have to be connected to a base station. So if you lose the tower while traveling in a train or a car, then the algorithm is something like this. First, the mobile phone will transmit with some power. If it is not able to find any base station, it will increase the power. If it is still not able to find, increase the power till it reaches the maximum power. And if you are in a train and there is no base station nearby, so by following this algorithm, mobile simply drains out all the battery.
When we are talking about the algorithms, like the spectrum sensing algorithms, you're having different class of algorithms. So what are the underlying algorithm or the methodology which you're implementing this software defined radio along with 5G on this networking?
Well, it's been a long time. I was working on cognitive radio. So
Yes.
the spectrum sensing is coming directly from the cognitive radio. But to be honest, I haven't seen any. It's been that it's too early to say, or maybe I'm making a stronger statement. I feel that the area is kind of dead, because I see this cognitive radio thing came up in 1998, and it's been 22, 24 years. Still, we don't have any commercial product in the market. So yes, you can do very nice theoretical work and publish papers, but you don't have any product in the market. There are super algorithms, very highly sophisticated algorithms, but without any product in the market, since it cannot be commercialized without the consent from the vendors, it's very difficult to come up with a product. And that's why I feel that we stopped working on this long back.
Okay, on a comparative basis, can you give some comparisons on existing algorithms?
You mean a comparison between what?
I mean, the complexity or the computational efficiency, all these things based on a comparison.
Well, I mean, if you see the computational complex, you mean the computational complexity of a 5G system, right?
Yes, exactly.
No, it is very high. It is very high compared to what not considering about the spectrum sensing and the cognitive radio. I'm just making a comparison of 4G and 5G system in terms of computational complexity. Yes, there has been significant increase in computational complexity, but at the same time, the 5G is becoming more and more green. It is becoming energy efficient also. A common belief is that if you use beamforming, active antenna, and massive MIMO, the power consumption will increase, but that's not correct. Basically, you are focusing the beam towards the user, and hence you have to transmit with less amount of power, because in LTE we were transmitting in all direction, the omnidirectional, and you were literally wasting the amount, the power which was not reaching to the user. But in 5G, it starts the beam-based communication is it in the very heart of 5G. So even with starting from the synchronization, there are SSB signals which are also beam-based, and then there is user-specific beamforming. So with this, the computational complexity has of course increased, because for the beam-based processing, you have to do some extra computation. But at the same time, you save on the power side. You save a lot on the power side.
So lastly, coming to the common man's questions, like B.Tech in undergraduate B.Tech program in electronics and communication, you're having a lot of the streams. Now the trend is towards the computer science. So as a graduate of electronics and communication, what do you think in future, how will be the application and demand of this stream in engineering?
Well, you also must have observed that regardless of any branch of engineering now, learning programming is a must. Without, you cannot do anything. The time has gone that we used to learn programming that so that we can find job in some software companies. No, you need programming even to work and excel in your branch also, be it mechanical, be it civil, be it computer science, of course, and be it electronics and communication. You need programming skills. And programming does not mean programming in C. There are 100,000 different programming languages you have to learn. It's Python, C++, Java, FPGA programming, and there are tons of them. MATLAB, LabVIEW, there are lots of them. So if you ask me about for the electronics and communication guys, yes, learning programming is a must. Even in electronics and communication, there are two parts. One is electronics and one is communication. So when you go higher in the career, you have to choose whether you go for electronics or communication. Both of them, you need very heavy programming skills. And when you learn any basic programming during your bachelor's, whether it's C, C++ or anything, you basically build up a foundation on how to solve a problem. And that thing helps you up when you go to either electronics or communication and try to learn a new programming language. If you're expert in C, C++, then it will be not that difficult for you to migrate to like MATLAB or Verilog or VHDL or anything, because basically you know how you are good if you are good with the problem solving skills, then it's the language is just a matter of learning the alphabets.
So thank you, Dr. Sumit, for spending your valuable time for this forum, Life Made Up of Questions. Actually, I'm so happy to meet you after long years, even
Yes,
though we
same
are
here.
in contact in LinkedIn or other social media platforms. So I'm so happy. And I still remember from that time you are associated with Software Defined Radio, Ramurthy sir at IIIT. So I
Yes,
wish
yes,
you,
yes.
yes. So I wish you all the very best and for your future projects. So thank you for spending your valuable time. Thank you.
Thank you very much for hosting me.
Thank you. Have a nice day.
Thank you. You too.